Let's stress test our understanding of attribute lookup and inheritance by working through a slightly more complex example. Here it is. I suggest that you pause the video and try to figure out what happens after you run all of this code on the left and then evaluate these three expressions on the right. What are their values? If you finish that, try to answer the question of which evaluates to an integer. B.z, 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 B, or none of those. So like I said, please pause and work on it on your own. We're going to go through the solution in 3, 2, 1. In order to solve a problem like this, you need to figure out what happens when you execute these three class statements and then these three assignment statements. Let's take a look. When you execute class A, you create a new class. A class is like any other value in the sense that it can be assigned a name, and the name that it gets assigned in the global frame is capital A, because that's the name that we gave it. Now the class itself has two class attributes. Z is -1 due to this assignment statement, and f is the function that returns b of x minus 1. This function, like any other function, does have a parent frame. All of the functions in this example have parent frame global, so I'm not going to write them in. So this structure was created by executing the first class statement. The second class statement creates a class B that inherits from A. And forever, this class will know that it inherited from A, or that A is the base class. It also has some attributes due to the body of this class statement. So n is bound to 4, and init is bound to a function that initializes self. In the global frame, this class is given the name capital B. Finally, the third class statement creates a class C which inherits from B. Since B inherits from A, any instance of C will have access to the contents of A, except for when it's the case that some name is repeated. So the class C, or an instance of the class C, will have an f that's different than A's because f is overridden. There's another definition of f, which in this case is the function that just returns x. This whole class is given the name C, capitalized, in the global frame. And then we execute these three assignment statements. Calling A introduces a new instance of A, and we'll call it A. Since there's no init method within the class definition A, there are no instance attributes that are set. This A instance is just a blank slate. Now we create B of 1. Calling B introduces a new B instance, and the init method for B is called automatically with self bound to the instance and y bound to 1. And then we have some expression about self.z, which depends on y. So since y is a true value, we're going to call self.f on y. Which f does it call? Well, B doesn't have any f, so then it looks in the base class and calls this f, which creates another B. Oh my goodness, that's complicated. Let's not worry about it just for the moment, and instead focus on the fact that z is set, self.z, equal to something, and it's whatever is the return value of this call to f. Whatever the attribute contents of this B instance may be, that instance itself is assigned to the name B in the global frame. And now we have attribute assignment to an attribute of lowercase b. So I look up B in the current environment. It's this instance. Setting n equal to 5 means that I add an attribute here. This has no effect on B's class or its base class. Instead, it's just a change to this particular instance. Now I think we're in a good position to review some of these. Eventually we're going to have to fill in what z was, but let's solve the first two here before we do that. So c of 2 dot n, here's an expression that has to evaluate to some object. In this case, it evaluates to an instance of the C class. Here's the C class, so we build a new instance. And what happens when you build an instance of the C class is that you automatically call the init method for the C class. Since C has no init, we look in its base class. Here's the init, which is this function here. So we're calling this with y bound to 2. If y, which is 2, is a true value, then we'll set self.z to be self.f of y. Now what is self in this case? Self is the C instance that we just created. So we're going to add a z attribute. You can see here in my slide that it's going to be 2. Why is it 2? Well, we look up self.f. What's the f function for this C instance? There's no f attribute here, so we look in the class. There's the f attribute, is the identity function. So we call the identity function on 2. We get back 2, and that gets bound to self.c. So z is 2 here. But the interesting thing is that c2, having been created, is only used to look up the attribute n. So when we look up the attribute n on this C instance, since n is not an attribute, we look in the class. N is not an attribute here, so we look at its base class. N is here, so the value of c2n is 4. If we had instead asked what's c2.z, we would have gotten 2. All right, is it the case that a.z is equal to c.z? Let's figure out what a.z is. A is this instance. It does not have a z attribute, so we look in the class. There's a z attribute is -1. So the left-hand side of this equality is -1. C refers to the C class. C.z is an attribute which does not appear here, so we look in the base class. No z here, so we look in the base class, and we see z is -1. So these are equal because, in fact, we're referring to the same attribute in two very different ways. Okay, a.z we already figured out is -1. And what's b.z? Well, b is this b instance, and it has an instance attribute called z. We never really wrote down what it is, but I'm pretty sure it's not going to come out -1. I think it's time that we figure out what it does equal. So, when this instance was created, we passed in 1 as the value for y. Self is bound to the instance itself. We checked that y was true, and so we called self.f on y. Since b is an instance of the b class, f refers to this. Because we look here, there's no f, so we look in its class, there's no f, and so we look in the base class, and there's f, which is the function that returns b of x minus 1. b of x minus 1 creates a new instance of the b class. But this time, we call the constructor on whatever x was, that's 1 minus 1 is 0. So now we're calling this on 0 for the second instance of b. Since 0 is not a true value, we set self.z equal to a C instance, where we pass in 0 plus 1 is 1 as the argument. So we're about to construct a C instance where we've passed in 1 as the argument to the constructor. C has no constructor, so we look in the base class and we find this constructor. Y is bound to 1, and 1 is a true value, so we set self.z for this C instance to be self.f. Now, since self is bound to the C instance, self.f is looked up here and then in the class for C, and there is an f there that just returns whatever was passed in, which in this case is y equals 1. Ta-da! Okay, so it's quite clear that this is -1, and this is some b instance, and those can't be equal. And now we can move on to which of these expressions evaluates to an integer. b.c is a b instance. b.z.z is a c instance. b.z.z.z is 1. And 1.z is nothing at all. That would be an error. So only this expression evaluates to an integer, and that integer is 1.